So, get ready, students. Today, I welcome you to solve ATP P4 questions of waves section with TPS. So, in this very first question is a student is investigating the passage of light through a transparent block as shown in figure 1.1. So, you can see incident ray is incident on the transparent block at point A. So here we have point A where the ray is incident. Now this is emergent ray, means ray is also going to pass out from this transparent block. Ray will pass out of transparent block. Transparent block. So the very first part here, the student looks through the block. He places pins so that two pins marking the incident ray and two pins marking the emergent ray all appear to be exactly one behind the other. On figure 1.1, A part says mark suitable positions for four pins, two on incident ray and two on the emergent ray. So dear students, remember whenever you are going to mark or place the pins, it should be kept as far as possible, one thing, as far as possible, and the pins should be in one line. Pins should be in one line. So I'm going to mark two pins here. You can place cross, I name it as P1. You can place dot and circle it. Then we can place two more pins. One is here, this is P3, and here we have P4. So this is one way we have done. Now B part on figure 1.1, draw the normal at point A. What is normal line? You know, it is a line perpendicular to the plane. So here we have a line, dotted line I'm going to draw. This is going to be the normal line at point A. So this is normal line. Normal line is perpendicular line to the plane. So you can see here we have a 90-degree as well. Moving to next part on figure 1.1, draw in the line AB. Draw in the line AB, measure and record angle of refraction R between the line AB and the normal. So A to B we have to draw the line. A to B we have to join these 2 points. So it will be somehow like here. So I'm going to draw a line here from A to B. So we have to find angle of refraction. Angle of refraction is angle between in normal line and refracted ray. So if I see here at a normal at point B, if I draw normal at point B, this is not going to be the angle of refraction. This is angle of incidence. So we have to measure this angle. So how to measure this angle? Suppose you have to use a D, use the protractor to measure the angle. So it is at 90. So if I rotate this somehow, if I measure this, it will be approximately, I would say, 20-degree. So it can vary. It can be 19, it can be 20, 21. It depends on the size of page as well and the diagram which is going to be printed. So I'm having it 20-degree. You have to use protractor to measure this. So now measure and record angle of incidence between incident ray and the normal. So we have to measure the angle of incidence. So where we have to measure angle of incidence, we have to measure on figure 1.1 and draw in the line AB. So angle of incidence we are going to measure. So for AB, this one is AB line. So we are going to measure the angle of incidence. So this angle will be this one now. This one. This is angle of incidence. So I am having the scale which is having protector as well. So if I rotate this, so what I'm getting here, you have to measure it by D. So I am getting this approximately 30-degree. Yeah, approximately it is 30-degree. Or No, it is going to be 32. I'm having this as 32 degree. So we are done with this question. Question number one. Now on question two. A student investigates the image formed by a converging lens. Here we have a converging lens. The student arranges the apparatus as shown in figure 2.1. So you can see this diagram. We have a triangular object here. Here we have an object. Lamp is connected, and lamp is also connected to the power supply so that we can switch on and off the lamp. So here we have a screen, and this is the distance between u is the distance between object and the lens. The illuminated triangular object is shown full size in figure 2.2. So measure and record the height age of the triangular object. So here you have to use your scale meter rule, which the students are having in their geometry box. So we have to simply measure this height. So if I measure this, I am getting this height between these two dotted lines, that is 1.6. I am having this 1.6. So it will be going to vary according to your paper size, or you can say according to the diagram, print of the diagram. So I am having it 1.6. So actually the story is you have to just measure this length. It varies again. I would be saying that it varies from paper to paper, size of the paper. So now B part, the student switches on the lamp and places the lens a distance of 20 centimeter from the triangular object. Adjust the position of the screen until a sharp image is shown. So, we have to adjust the position of the screen or position of the lens so that we can get sharp focused image, means clear image of the triangular object formed on the screen. So the image is shown full size in 2.3, figure 2.3. So measure the height age of the image on the screen shown in figure 2.3. So we have to measure this height. So dear students, again we are going to measure the distance between these two dotted lines. So the distance is, it is for my paper, it is 1, 2, 3, 4, 4.9. I am having this. So I will be writing here 4.9. Unit is very important, centimeter. So now part 2 says calculate the value of 1 over h, means we have to take the reciprocal of this. So 1 divided by 4.9. Give your answer to two significant figures. So this is very important. Your answer should be in two significant figures. So 4 divided by 4.9, you are going to have the answer that is 0.204. So what I'm going to do, I'm going to make it to two significant. So if I round this value, it will be 0.2. I think I am having one more number. Yeah, it is 20408. So it will be approximately 0.2041. Then I have to make it to two significant. So you can make it to 0.20, or you can write it 21 as well. 21 is also acceptable. So we are done with this. Add your values for h and 1 over h in the table. So here we have to write the heading. Heading is already given, but its unit is missing. So you have to write the unit. Its unit will be 1 over h. This, when I take this unit in the numerator, it becomes per centimeter. So write it in this format. So value of h is 4.9, and 1 over h is 0.2. So you have to write all the values in two significant format. Two significant format. So you can see in the table all the values are in two significant format here. So as the value of h is increasing, as the value of h is increasing, you can see the distance of object is decreasing. Or in other words, you can say as the distance of object is decreasing, or you can say increasing, the value of height is decreasing. If this is increasing, the other is decreasing. So anyhow, this is just your comparison. So now we have to calculate all these values, 1 over 3.9. So no need to write here. Students, write here the working of this. So Just write the answer here after calculation. If you want to do the working for your understanding, you can do somewhere here. 1 divided by 3.9, it comes out 0.256. So I will be writing 0.26. Then 1 divided by 2.6 will be equal to, if I calculate this, 1 divided by 2.6, it is 0.384. So I will be writing 0.38. Then 1 divided by 1.6, if we solve this, 1 divided by 1.6, it comes out 0.625, which is approximately 0.63. So no need to write this unit here, students, because we have given the heading here already. So no need to write the unit here. Then we have to divide 1 divided by 1.1. So if I solve this, 1 divided by 1.1, it is 0.909, which is 0.91. So we are done with this C part as well. I hope so. This is clear to you. Now they are saying we have done, but the part is this: complete the headers by adding appropriate units. So I have done this for you. Part 2, complete the remaining values of 1 over h and add them in the table. So we have done the remaining values as well. Now D part is the screen is a square sheet of white card of side 10 centimeter. Look at the table 2.1, or you can say look at the data in table 2.1 and suggest why the student does not use values of u which are less than 10 centimeter. So you can see here what is happening. Height is going to be increased as the value of u is decreasing. Value of u is decreasing in this way. So height will be increasing. Height of image, this is image height. So the student is not taking the value less than 20 centimeter because the object become very close to the lens. When object come very close to the lens, image becomes too big. So I will be writing that image will not fit on the screen. Suppose here we have a screen, here I'm having a lens. So if I bring the object very close to the lens, what happened? The image will become too big, which is not going to fit on the screen. This is one way. Or you can say object inside focal length creates virtual image. So virtual image will be formed. When object is very close, image is not going to be formed here. So we have to draw the dotted lines somehow like this. So where they intersect, we will be getting the virtual image. So 1 mark question, I'm writing this. Moving to E part, now we have to plot the graphs. So this is a dangerous question of the ATP because graphs are very important and it is having 4 marks, 3 marks question. So the very first thing, whenever the graph is given to you, you have to label the axis. On the grid provided, plot a graph of 1 over h on y-axis and u on the x-axis. So dear students, I'm going to take 1 over h here and slash and then place its unit. That is r. Then on the x-axis, you have to take u and write the unit as well. So we have labeled the axis. So hope so this is clear. Now start both axes from the origin. Sometimes it is mentioned that you are not supposed to start from the graph from the origin. So then you have to be very careful. But at this time, we have to start from the origin and we have to use best fit straight line. We have to draw the straight line of best fit. Best fit means you can say same points above or below the line. So this is going to be the best fit for you. So now dear students, we are going to take these values. So be careful regarding the scale. So because you have to cover more than 50% graph. So for you, I'm having the values. First of all, I write the values somewhere here. I'm having 1.1, 1.6, 2.6, 1.1, 1.6, 2.6, I think then 3.9 and 4.9, 3.9 and 4.9 because I have to scroll this page again and again. That's why. So for 1 over h, I'm having 0.2, 0.26. I'm having 0.2, 0.26. I think then 0.38. Then I'm having the value 0.63 and 0.91. 0. Oh, I forgot 63 and 91. 63 and 0.91. So be very careful that this value was here. This value is for 1.6, this value is for 2.6, 0.26 is for 3.9, and 4.9 is for 0.2. So this is value of 1 over h. So I have to set the graph here. So I take that we have to go till 4. So I take 10 boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 boxes, and again I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because we have to set the scale very suitable one, not the awkward one. So nearest 1 over 2 square we have to use. So half of the square, but I'm using this one small box to equal to some value. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's the value. Then 2, 4, 6, 8, 9, 10. Okay, my this scale is set. I will be taking this as 1, 2, 3, 4, and 5 because 4.9 is the biggest value for me and it is going to be covered here. Now we have 0.2 and I have to go till 0.91. So again, I'm going to take 10 boxes here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is, I suppose it's 0.1. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think we have to set it to 0.2, 0.4, 0.6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because if I take it 0.1, then the space is going to be less for me. So grid will get short on the vertical axis. So I have set 10 boxes, 10 small boxes equal to 0.2. So here it would be 10, I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this will be 1.0. Now we have to mark the point. Life is easy now for us. So at 1.1, we have the value 0.91. So 0.91 is somewhere here. You can use scale so that this is your 1.1. So 0.9 is on 5 boxes. So it will be somewhere here. So dear student, remember you have to place the cross here. Either you place cross on the point or you place a dot and circle it. So best is to use cross. Because when you are going to draw the line, dot is going to overlap with the line, so it is the point will not be visible. If you draw the cross, it is going to be visible that here we have a point like this, like this. Point will be visible for you. So now we have 1.6. On 1.6, I am having the value 0.63. So 1.345, and here I'm having 1.6 and 0.63. So point is somewhere here. This is 2 and somewhere it will be here. Then I'm going to have 2.6, 2.4, 5, and 6 is here. And the value for 2.6 is 0.38. So the value is somewhere here. Then I'm having the value 3.9. Okay, 3.9 is here. And on 3.9, value will be 0.26. 1, 2, 3, 4, 5, 6. So here we have the value because one small box is equal to 0.22, you can say. So yeah, I think I did little mistake. Let me recheck it. 0.222426. Yeah, it will be somewhere here. 0.26. Sorry for this. So now last value 4.9 and on 4.9 I'm having value 0.20. Okay, so we are done with these points. This point is somewhere here. Okay, so cross here, one cross is here, one cross is here. So we have to draw the best fit line. So same number of points above or below the graph. So it would be somehow going to be like this. It would be, yeah, it would be the best point is here. So I'm going to draw a line here like this. So this is the best fit line. No, it is not going to be a best fit line. I have to redraw it because 2 points were going above this. So it will be somewhere here like this. So it is going to be a best fit line like this. Actually, what is happening? This point is having a huge gap. So that's why here we are taking above the line 2 points and below we are taking 3 points. So more points we are taking below side because their gap is smaller from the line. So this is going to be your best fit line. So whenever the line is going to be plotted, next question can be of gradient. So gradient formula you have to remember y2 minus y1 over x2 minus x1. So I don't know whether they are asking. Yes, they are asking. So we are on part F. Calculate the gradient of M of your line. Show all working. When they say show all the working, you have to show the working and indicate on the graph the values you use. So I'm going to take some points. I'm going to mark those points. So one point I will be taking this one. And I have to draw the dotted line here. Then here you have to use the scale for this like this. This is 1 point and this point is 4.9 comma it will be 0.20204. It will be 0.12. So I take 1 point somewhere here on one. This point I take. You have to you can draw the triangle as well for this. So I can erase this line if you want. We will be getting the triangle. If you don't want to, you can keep it, no issue. So now this point is 1 comma it will be 0.78. Two significant numbers we have to take. So we have to do the calculation. We have marked the values. So to calculate this, m is equal to 0.78 minus 0.12 divided by 1 minus 4.9. I'm taking this as x2, y2. This is x1, y1. So if you calculate, slope is decreasing, you will be getting the negative uh, gradient here. So what the value is 0.78 minus 0.12. This is 0.66 divided by 3.9. Negative sign will be there. So divided by 3.9. So the answer is negative 0.17. So minus 0.17. So this is the gradient here. So we are done with this part. Now we have to calculate the focal length of f of the lens. Use your values of h from part A and the equation this one. So we have to substitute the value of this gradient, that is 0.17. 1 divided by 0.17 times height, and the height which we have calculated h, that is this one, 1.6. So substitute the value here, 1.6, and you can calculate the answer. Now, key part, when measuring the height of the image on the screen, the student's hand and the ruler obstruct the light from the object and prevent it from reaching the screen. So Suggest one improvement to the apparatus used by the student to overcome this problem. The problem is that student's hand and the ruler obstruct, or you can say distract the light, or you can say create the hindrance on the path of the light which is coming from the object to the screen. So, what is the improvement they are asking? So, I would suggest here that you can use translucent scale. Translucent screen or screen, not scale. Translucent screen means then no problem of such stuff is going to occur. Yet you have to adjust the screen. Then other is that use graph paper, so that you can read the uh, distance. You can see where the image is plotted, what is the scale, what will be the size of the image, so you can use graph paper for that purpose. So this is what we can improve, or you can say you can use a clamp ruler, means you attach the ruler by the side of the screen. So I would be saying that use a translucent screen and measure at the back, at the back of the screen, whatever you are going to measure. So we are done with this big question of 14 marks. So now we are having question 3. Do students determine speed of sound in air by an echo method? So one student stands a long distance away from a tall building. By the way, whenever there is a graph question, I suggest my students to spend maximum time. Don't spend too maximum time that you forget that the time of the paper is over and you are still on that question. So the student bangs a drum to make a loud sound and both students listen for the echo. So student is banging that drum and then sound is going to be created. So we have to state two additional pieces of apparatus that are needed in order to determine the speed of sound. So speed is equal to distance by time, or you can say by echo method speed is equal to 2d by t. So we need what? We need to measure distance and time. So these are going to be two additional operators. That the tape measure is required, or you can say meter rule, but the tape measure is better. Sometimes in the mark scheme it is written trundle wheel. So you can remember this. It is also used to measure the distance. It is also used to measure the distance. So tape measure is one, and the second is stopwatch to measure the time. So we are done with this. State the measurements that students make and how they carry out the experiment to find the value of for the speed of sound, and state any equation used. So first of all, student measure the distance between the building and the point where student will bang the drum. Bangs a drum. One thing. Then student, another student, the second student basically is going to do this. Student will measure the time when drum is banged and echo of sound is heard. Echo of sound is heard. Then use the equation that is speed is equal to 2d by t, and the student will be able to find the speed of sound. We are done with this question. Now we are on another question, question number 4. A student investigates the speed of water waves. A rectangular plastic tray has a layer of water in the bottom. You can see here we have layer of water as shown in figure 4.1. One end of the tray is lifted gently a small distance. You can see here from here the tray is lifted up as shown in figure 4.2. A. When the water is still, the tray is lowered quickly. This causes a wave to travel across the surface of the water. Means when this tray is again lowered from this end, wave is going to be moved from here. And you can see figure 4.2b. The wave is reflected by the ends of the tray and travel backwards and forwards several times. The student estimates the time for the wave to travel one length of the tray to be about 1 second. Means from here the wave is going, it takes time sometime, it will be coming backwards, and this length of the wave you can say is going to be 1 second, or this is 1 second. Suggest a reason why the student decide to measure the time for the wave to travel 5 lengths of the tray. So, you know, in this way, error can be reduced, or you can say average time can be calculated. So, average time can be calculated, or you can say reaction of the time can be reduced. So, suggest why student decide to measure the time for the wave to travel 5 lengths. Student can find more accurate time for one length. Because if the student is going to measure the time for this only length, what happens, it is this time, this will take smaller time. Time is small, so the value will not be accurate. So student can find more accurate time for one length by dividing the length by 5, and the student will get the length of one wave. Length of one wave. If the student is going to just measure the time for one wave, then it becomes difficult. The time is very short, large error will occur. So you can write in that way as well if you are interested. I think that will be more simpler one. So I have explained to you what the cause is here. So length of one wave will have small time. So reaction to measure the time will create large error, big error. So the ends of the tray slopes outward. The tray is somehow like this, having slope outwards. Explain why this makes it difficult to measure accurately the distance traveled by the wave. Because the length of the tray varies. You know, if this wave is coming, it is hitting here, it is going to have different length. Wave is coming, it hits here, so here we have a difference in the length. So this is the reason. So I think that length of the wave varies. This is the reason. So we cannot place a ruler or scale or meter rule very close to the water. So length of the wave varies. Moving to next part 2 of this quest, part B. Describe a possible method of measuring the distance traveled by the wave. You may use a diagram in your answer. So very best way is that you can place set squares here and then measure the distance between the set squares, or you measure the reading from the top. So this is possible. So if I draw a diagram here, here we have suppose a wave or water in this like this. So what I'm going to do, I'm going to place set square here in this way, place the set square here in this way, then you can measure this length. So you are basically dealing with this length of the wave. So use set squares. You are having these set squares in the geometry of your uh, geometrical box which you carry with you. So use set squares and measure the distance between the two set squares. So simple is this. Moving to C part of this question. The student measures the depth D of the water. He has two identical 30 centimeter rulers. Part of the ruler is shown. You can see this. Explain why it is difficult to measure D using only one of the ruler. Because might be you can say there is a gap between these two scales. So this is the gap. So very small gap is there. So you can say some error can occur. So scale is not going to measure exactly from the zero. So this is the reason here. So the reason if I write, I would be saying zero mark of the scale is not at the edge of the meter rule. So this is the problem with the ruler that if this I'm having this as a tray, if I place a scale here, so 0 is somewhere here. So I'm going to unable to measure this. I'm very unable to measure this gap. So this is the reason why single meter rule is not fine. So describe a method of measuring D using two rulers. You may use a diagram in your answer. So I have to draw the diagram as well, and you have to give the reason, describe the method, that why, how you will be using the two rulers. So first of all, I will be measuring the gap of this tray. So I will be placing 1 meter rule inside the tray. Suppose I will be getting this one length because 0 is starting from here, and I will be placing one more scale, and I place that scale suppose somewhere out of the tray, somewhere here. So I will be measuring the distance between the two or length between the two. Then suppose I get one length L0 from here, and from here I will be getting length 1. So space, or you can say width of the space or width of the tray, we can find that will be L1 minus L0. So in this way, we have to neglect this, whatever this scale or size will be. So we will be able to measure in this way accurately. So we will be saying measure the gap of meter rules so that edge of the edge of the meter rule, which is not starting from zero, which is not starting from zero, can also be considered. Reading is also considered. So we are done with this question. Now I think we are on question 5. This is going to be the last question. Oh no, we have another question as well. So it is little lengthy. No issue. A student makes a periscope using a cardboard, or you can say tubing and mirrors. He looks through the periscope at a flower shown in figure. So you can see this shape is a periscope, and this is the example of some total internal reflection, or you can say only reflection. This is the example or application of reflection. Two rays of light are shown going from the flower to the mirror. So you can see two rays are shown to you here. Complete the ray diagram in figure 6.1 to show both rays as they reflect at mirror 1 and then mirror 2. So dear students, we have to draw the normal line here that should be perpendicular to the plane. So it will be somewhere here. So I have to draw the normal here. This is going to be the normal. Then one more normal. It will be here because two rays are there. So two normals we have to plot. So whatever this angle is, at the same angle you have to draw the straight lines. So it is going to be till here. Then the second one from here. Please draw the straight lines like this. Now again, you have to draw the normal and the ray will reach the eye. So be careful regarding the measurement of angle. So you have to use protector or you can say D. So I know they are at 45 degrees. So the rays will come to the eye, observer's eye in this manner. You can see how the two rays are going to enter here. So one is this and the other one is going to be this one. So we are done with this. Now you have to draw the directions as well. So the directions will be in this manner I have shown you. Now on part 2, draw an arrow on each ray to show the direction. We are done with this. We are done with this part as well. Now the part 3 is on figure 5.2 shows the original flower. Shows the original flower. You can see on figure 5.2, sketch the image of the flower as seen by the student through the periscope. So you know we are using mirror. So in mirror, what is going to happen? Same size image is there, same size image. One thing, but image is upright means same way the image will be as the object. Image will be upright, and the meaning of upright is same as object. Image is the same as the object. So you have to be careful regarding these 2 points. So we have to draw the flower here. There is a difference. One figure is this one. Here the image will be little inverted, means upside down. Upside will be down. Here it will be same size. So image will be same size, but here we have to draw it upside down. So you are good in drawing. So what you have to do, you have to draw it somehow like this, like this, like this. I'm not good in drawing, so students draw very good diagrams. So it will be somehow like this. And here you have to draw the leaves like this, like this. So this is how the image will look like. Now B part, a second student also makes a periscope. Her periscope is shown. It's little different. So state how the image of the flower seen by the second student differs. Here it will be same as the size of this object, same size of image will be there, but it will be upright, upright. So I will be writing here image will be of same size. Even here the image is of same size, but it is going to be upside down. So we are done with this. Now we are on question 6. In this question, a student is given a plano-convex lens. So this is a plano-convex lens. In this lens, figure 6.1 shows the plano-convex lens. It has one curved surface and one flat surface. So plano-convex lens is going to be flat from one side and it is going to be curved from the other side. This is basically a converging lens. It is also mentioned to you. So it is a planning question, by the way. Remember, planning question will be given to you in the exam, and this question will be last question mostly. Mostly, always it is last question, and it is going to be one question in the paper. So the student predicts that the lens has two different focal lengths. Two different focal lengths are there, one on each side of the lens. Means if the lens is used from this side, focal length will be different. If the lens is used from this side, focal length will be different. Describe an experiment the student can perform to test this prediction. In your account, means in your investigation, state any equipment used. So what additional apparatus is required? You have to write that. You know, screen is not given to you. So equipment, or you can say additional apparatus required is screen, and you can say ray box because we have to drop the rays of light as well. Ray box is required. You can use of object. Object is required. Object is not given. You can write about meter rule to measure the distance. So 2 to 3 additional operators are fine. So We are done with this. But main apparatus is very important, like screen, ray box, use object like this. Now draw a labeled diagram of the equipment used. So space is given to you. You have to use the draw the labeled diagram. So I place lens somewhere here. This is going to be the lens. This is the center of the lens and principal axis is here. So here you have the object. You can use illuminated lamp as well, lamp with power supply. You can write that in the equipment as well. So, but that is not too important. Important things are this. So I can draw a lamp here as well. So here I am having a lamp and this is power supply. So you have to label it as well. Object, this is lamp, power supply, lens. So here we have the distance between object and the lens, that is u. Then we have the distance between center of the lens and the screen. So here I'm having the screen. So we are done with these two parts. Now describe how the experiment is used. So what we have to do, you have to uh, place the object, rays from the object will pass from the lens and then rays will it is a converging lens, so rays will converge on the screen. So to obtain clear, rather than clear, you can use sharp focused image. So to obtain sharp focused image, move the screen forward and backward. Oh, it's fine. Move the screen till here. It is fine because we are not having this a big question, so it's fine to write here that move the screen. So we are done with this. Now last is explain how the student checks his prediction. So prediction is that you have to reverse the lens and then see what variation is occurring. So according to that, you can understand. Use use the other side of the lens, reverse it so that same procedure can be done. Procedure can be performed to see how focal length varies, how the focal length differs. So this is the main agenda here, two different focal lengths of two different sides. So dear students, we are done with this. Here we have 6 questions regarding waves section in the alternative to practical paper, ATP, paper 4. And here one question would be regarding waves, that was of planning question. One question was of planning, that we have to design the question. And 5 questions of the ATP were regarding simple story based. So I hope so you are clear that how we have to attempt the paper. So take care, stay blessed.